Now, when we talked about parabolas before, we didn't get into the specific details of the parabolas. We basically focused mostly on the vertex and axis of symmetry and maybe the intercepts. But here, we're going to define some terms here that are important into fully understanding parabolas. And we're going to talk about a focus and the directrix as well as the parabolas. So read this definition here. It says a set that consists of all points in a plane that are equidistant, the same distance from a given fixed points in a fixed line in a plane, is called a parabola. So if you go back and think about some parabolas we had before, you could actually have a fixed point here and say another fixed point here, and let's say the distance was, say, a certain value. Let's say the distance was this length. Well, then basically if you defined all points that are the same length from this point here and this point here, then it would actually define points on a parabola. So let's say that these two pieces are the same length. If I can draw it here, let's say these two pieces are the same length. Well, there's a point right there. Well, if you looked at other points that were the same length and plotted them all out, it would give you a parabola. That's not a great picture, but I can show you this later in more detail. So this definition is going to be a little bit different from what you're used to. So it's a little bit confusing, but let's look at it. If your parabola is written in the form x squared equals 4py, now 4p is just the constant, so x squared equals some constant times y. Well, then that focus is the point 0p, and the directrix is the value, is the line y equal negative p. And so the axis is actually x equals 0 because the vertex is at the origin, and this would open upward. Okay, now if you had x squared equal minus 4py, in other words, if the constant was minus, then the focus would be the point 0 negative p, and the directrix would be y equal p, and again the y-axis would be x equals 0, but this time the parabola opens down. Okay, so let's take a look at this particular example. Let's say you have y equals 2x squared. Okay, now what we need to do to identify the p, we need to actually write this in the form of x squared equals something times y. So if we solve this for x squared, we get this equation, x squared equals 1/2 y. Well, whatever the coefficient of y is, that has to be the 4p. So here the 4p is actually 1/2. So the 4p is 1/2 because that's the coefficient of y. And then you can solve this for p, and you can get that p is 1/8. Now, so that means that the focus here, and we're dealing with this case here because we have x squared equal a positive number times y. So the focus would be the point 0p, so that would be the point 0 1/8, and the directrix would be the line y equal negative 1/8. I think a while ago I told you different, that it was 2 points, but it's actually the points that are the same distance from a point and a particular line. And the axis in this case would be the y-axis, and this is opening up since 4p is actually a positive number. So let me show you a picture of that so you can see what I'm talking about. So if you'll remember, the p point was right here. That was called the focus, and that point is the point 0 1/8. Okay, and this line down here is called the directrix, and actually this is the line y equal negative 1/8. Now, if you took every point on this parabola, and obviously I won't do that, but I'll just take a couple of points. If you look at this point here on the parabola, it turns out that this point is the same distance from the focus here as it is from the directrix. See how the two red segments are the same length? Well, then I picked another point up here, and I drew blue segments from the focus and then a blue segment to the directrix, and notice that these two blue segments are the same length. So basically every point on this parabola has that property, that the distance from the point to the focus is the same as the distance from the point to this directrix. And so that's what they mean by that statement in the very beginning. Okay, now let's look at another example. So let's say it's written in this form. Well, since the y is squared, we want to solve for y squared, and you can multiply both sides by -4 to get y squared equals -4x. Well, since this is negative, then we know -4p has to equal -4, and so that would mean that p equals 1. So the directrix here, the focus is actually the point 0, -p. So let's see, 0, -p. That should be the other way around. It should say -p0. So that, I'm sorry, that's the wrong one. Never mind. We're dealing with this one. Okay, so -p0 is the focus. So that would be the point -1, 0. Sorry about that. -1, 0, and then x equal p would be the directrix. So x equal p would be x equal 1, and the x-axis is the axis of symmetry, and since this is the y squared version and the constant is negative, it's got to open to the left of the parabola. So now if you look down here, this point here is the point -1, 0. The focus is that point -1, 0, and then the directrix here is this line x equal +1. Okay, and now if you were to pick a point on that line, let's just pick a random point. How about right here? Okay, and so the distance from the focus to that point would be that length, but then you would have the same distance. Let me see if I can do this. You'd have the same distance from that point to the directrix. Okay, so basically these two segments would be the same length, and so that's the okay, so let's look at number 2 here. You've got x equal -1/4 y squared. So let's solve that for the squared term. So y squared equals -4x. Well, since this is negative, I'm going to be dealing with this one. Y squared equals -4x here. So you have y squared equals -4px. So we're dealing with this particular parabola. And the focus of this particular parabola, well, let's find p. So if -4 is the coefficient of x, then basically we know that -4 is actually -4p. And then if you solve for p, divide both sides by -4 and you get p equal 1. Well, then for this particular parabola, the focus is the point -1, 0, or -p0. In this case, that'd be -1, 0. So it would be this point right here, which is the point -1, 0. Okay, and then the directrix would be the vertical line x equal 1, and that's this line here, x equal 1. And notice here I picked a point right here, and these two lines are actually to show you that when you pick a point on the parabola, that the distance from the focus to the parabola and the distance from the directrix to the parabola are the same distance everywhere on that parabola. And so, and to finish this off, the x-axis actually is the axis of symmetry, and since the coefficient of x was negative, then this opens to the left. And so there's two examples of how you can determine this information. So identifying the focus and the directrix is just a simple matter of first solving for the squared term, and then determining which parabola you're dealing with. Here I'm dealing with x squared equal a negative constant times y. So that would be this one. So negative 4p would have to equal negative 5. And then you can solve for p and get 5/4. And then the focus for that particular parabola is 0, negative 5/4, and the directrix is the line y equal positive 5/4. On the next one I have x equal 3y squared, and if you solve this for y squared, you get y squared equal a third. So in that case, 4p would equal 1/3, so p would be 1/12. Okay, and so the directrix here would actually be the point 1/12, 0, because when it's positive, let's see, when it's positive, the focus is the point 0p. Let's see, it's actually this one, I'm sorry. It's the point p0 when you have a positive value. So the point p0 would be the point 1/12, 0. And then the directrix is always opposite of whatever this number is. So the directrix would be the line, let's see, I believe I should have written x, right? Yeah, it should say x equals, because this is y squared, right? This is y squared. That should say x equals negative 1/12. And so that's the focus and the directrix for that particular parabola. So now, if you were to graph this one, your focus would be here at the point 0, negative 5/4, and your directrix would be this horizontal line y equal 5/4. And so when you graphed it, I can't do it perfectly, but it would look something like this. Okay, and so it would open down. And so that's basically what the graph of that one would look like. And let's look at the graph of the other one real quick. So the other one would have focus, the point 1/12, 0 here, and the vertical line would be the directrix, which is negative 1/12. And if you graph that one, you know, it would look something like this. So that's about as good as I can get it. But anyway, that would be the parabola there. Now, if you want to investigate those not centered at the origin, one would simply shift the values of the focus and directrix according to vertical and horizontal shifts. So for this particular parabola, if you had y instead of y squared, let's say you had y minus 1 squared equals 1/3 x plus 3. Well, basically the parabola would look exactly the same, except what you would have to do is you would have to shift the x values down 3 units, and the y values would have to be shifted up 1 unit. And that goes back to our transformations we learned earlier in the chapter. When you replace y with y minus 1, it's going to shift it up, and then when you replace x with x plus 3, it's going to shift it to the left.